Here is 1.6, day 2, part 3. So we're going to continue graphing some of these transformations. What is the shape of this parent function? A V. So let's just graph that first. All right, there's my graph. My parent function. All right, what is the negative in front of the function going to do? Reflect over the x-axis. What is the 2 going to do inside the function? It's inside the function. A multiplier inside the function. Has to be something with horizontal. It's inside the function. We have to reciprocate, always think opposite. So we're going to horizontal, scaled. Technical difficulties here. There's been some issues with the district today with their internet, so I'm wondering if this power outage thing is causing a problem here. Horizontal, scaled by, and now we have to reciprocate that 2 to 1/2. So on the x-axis, what value am I changing? On the x-axis, the x. So I have to remember I'm going to be changing the x values by 1/2. The last thing, plus 3. What is that going to do? It's outside the function. So think about horizontal, it's going to move it up 3. All right. So when I do my problems, I like to see what's all happening first, and then I go out and graph it. And you might want to do these in steps. So let's do the reflection first. So it's going to reflect about the x-axis. So I'm just going to flip it down. Then let's move it up 3 units. So we're going to pick up that green function and move it up 3 units. So I'm going to just change to black now. We're going to pick up this critical point of 0, 0 and move it up 3 units. So 1, 2, 3. Again, my shape has not changed. And then I save the shape for last, the scale factor last. So what it's saying is take those x values. So my critical point right here is 0, 3. And then this next point is 1, 2, and negative 1, 2. We're going to multiply what value? The x or the y? The x by 1/2. So this 1 is going to be multiplied by 1/2, so we're going to go over 1/2 and then up 2. and then left 1/2 up 2. And that final red is my function. The vertex is still 0, 3, and then my next point is 1/2, 2, and negative 1/2, 2. All right, let's move on down to the next question. G of x equals 1 over x plus 3, and that's all together, and then minus 2. What parent function is this? It's a fraction. It's one we don't talk about a lot. Reciprocal, 1 over x. So let's graph that reciprocal function. Think about when we graph the reciprocal function. Does it have some asymptotes? Domain restriction, x can't be what? 0. Yay! All right, x equals 0 here. And then the horizontal. And we have a point in here. Let's go 1, 1. Just kind of draw it along that blue asymptote. And then negative 1, negative 1. All right. So there is our parent function. Now we have two transformations. The plus 3 in the denominator. What's that telling me? It's inside the function. Inside the function. So we're going to move left 3, horizontally left 3. And then the minus 2 is where? Outside the function. So where is that going to go? Down 2. So my recommendation is probably just go ahead and move those asymptotes and then graph your two curves. So we're going to move the blue line to the left 3, the vertical line. And then the horizontal asymptote, where it's 0, is now going to move down 2. You might just want to erase the blue and the black, the blue that's going on there, and graph the new curve. It's getting kind of messy there. So now, here's my red curve. And my red curve. You should label as two critical points too when you're graphing them. Okay, last question. 1 over x minus 3l squared plus 4. I'd say this one we don't need to write down. If you want to, you can. The shape is a little bit different. This one, what is the parent function? We talked about it yesterday. 1 over x squared. Looks similar to the one we just did. But now where are both of my curves going on? They're going in first and second quadrant. So they have the same asymptotes, but now my curves are in first and second quadrant. Then you just tell me what happens now. Minus 3. Where does it go? Moves to the inside. Moves to the inside. right 3. And then up 4. And we would do the same thing as the last example. Move those asymptotes and then draw your curves. We're going to move on. I forgot there's one more, a step function. Again, I'd say you probably don't need to write this one down. We'll just quickly graph it. So the step function, let's just graph that parent function first. So we remember the critical point is at the origin. So closed circle to open circle. And step up, closed circle to open circle, closed circle to open circle. Let's go backwards 1. All right. Now, what is the plus 4 inside going to do? Inside, so left 4. And what is the plus 3 going to do? Up 3. And then you just pick up those blue ones and move it. I always start with the critical point, 0, 0, and move it first, and then draw my little pretty ladder. So we're going to move left 3, or left 4, 1, 2, 3, 4, and then up 3. So there's my start. Closed to open, closed to open, closed to open. All right. Here is our assignment for today. You can just continue on with what you started yesterday. I assigned these yesterday. You'll just, if you didn't get the 9 through 12 done because you weren't quite there with the transformations, you should be okay now. And then the rest. Notice there is a quiz on Friday. There will be 8 questions on graphs, so we'll give you 8 equations. You figure out what the transformations are, graph it out on the graph paper. And note, identifying a few points or asymptotes if there are asymptotes that are going on. Tomorrow come in to ask questions, and that will be our day tomorrow, is wrapping up 1.6.